to your video for day 3. Today we are doing something called verifying equations, and I think you're going to like this one. When you verify the equations, I already give you what they are equal. I'm telling you the equality. However, I don't want you to take my word for it. I want you to prove it. So when you verify the equations, unlike the simplifying, you didn't know what it was equal to and you just had to simplify it down to one term. Today I'm going to tell you what the other side is, and you just have to prove it to me. So the steps are very similar. You still need to show each step, especially when you're using the identities. You need to work vertically, and you must use the equal signs. Very important, especially going forward into the AP classes. The tools, still going to use a lot of different things. You're going to use your identities, you're going to do the common denominator. Sometimes you've got conjugates and factor, lots of factoring. I cannot emphasize this one enough though. You must start on one side of the equal sign and prove that it equals the other. You cannot assume the equality and work on both sides at the same time. You can study the other side to see the goal, but you can only manipulate one side. The tendency is to play with both sides and make them equal to the same thing, but you can't do that because you cannot assume this equality yet. So I'm going to work 4 problems with you that are in your practice problems. I'm just going to go through and show you how to do these. And again, the way I'm doing them, there may be another method to verify it and to show it, but there's not just one way to do it. But I am going to work these 4 problems, and then you will finish the other 4 when you get to class, or the other problems, more than 4. And if you want to print it off and work on the worksheet, you can. You do not have to. You can just go ahead and copy these bullets in your notes and then work the 4 examples. All right, I'm going to start here with example 2. And typically, you're going to want to start from the side that kind of looks worse. That's messier. That is the more complicated side, and you're going to simplify it to the other. Now, when you do this particular problem, I want you to recognize that there is some factoring you can do here, because I see that I've got secant to the 4th minus tangent to the 4th equals 2 secant squared minus 1. Now, you may think with your Pythagorean identities, I can't do anything to the 4th power because I only have squares. Yes and no, I understand that, but this can be factored. Very much like if I had x to the 4th minus y to the 4th, I could break that down into x squared minus y squared and x squared plus y squared. So I can do the same thing with the secant and the tangent. I don't need to worry about changing anything yet to another, from tangent squared to secant squared. I'm not going to do that yet. I'm just going to break down these 2 terms in a similar fashion right here. So this side, secant to the 4th minus tangent to the 4th, would be secant squared minus tangent squared times secant squared plus tangent squared equals. Now, I'm not going to even copy this other side. I'm just going to work it like I'm simplifying, and then magically, poof, it's going to equal the other side. Let's see what happens. Now, knowing your identities, can you see how one of these is going to disappear? I want you to think about it for a minute. One of those goes away. And if I take this Pythagorean identity and I subtract the tangent squared and move it over here, do you see how that equals 1? So this factor right here goes to 1. And you're left with secant squared plus tangent squared. Well, that's great, except look at where you want to go. All right? You want to get to 2 secant squareds. So I need to get rid of the tangent squared. And again, I'm going to use this Pythagorean identity. Instead of just tangent squared, I'm going to subtract that 1 and move that over here. And I'm going to have secant squared minus 1. So this becomes secant squared plus, and instead of tangent squared, we're going to have secant squared minus 1. Well, now look at what you've got. You've got secant squared minus 1. So how many secant squareds do you have? You have 2 of them. Minus 1. And that equals then your other side. Ta-da! We did it. So if you had looked over here and this one had a tangent squared, right, then you would have made the substitution for the secant squared. So that's what I'm saying. You look at the other side. Kind of helps you to know the direction, but you cannot use the other side. All right, let's try another one. I think I said I was going to do number 9. Yes, 9 and 11. All right, and 13. So let's look at number 9. Number 9 says secant minus cosine equals sine times tangent. And you can make an argument as to which side is harder, which side you want to use to start with. And you can probably do it from both sides, meaning you could start on the left, prove it equals the right, or start on the right and prove it equals the left. I'm going to start on the left, but if you would like to as a challenge, you could do it and practice the other way, going from right to left. So I'm going to rewrite secant. I have nothing squared. I have nothing I can substitute right away with the Pythagorean identities. So I'm going to basically take things back to sine cosine. Secant is 1 over my cosine, that reciprocal identity, minus cosine over 1. All right. I am subtracting fractions, so I need a common denominator. And this fraction needs a denominator of cosine x. And we'll push that equal sign out a little bit. So now, in the numerator, I've got 1 minus cosine squared over, so weird x, over cosine x. Oh, but 1 minus cosine squared, right here, 1 minus, if I subtract the cosine squared and move it over to the right, I'm left with sine squared. So this reduces to sine squared over cosine x. Now, this is important because you have to look to see where you want to go. I want to have a sine by itself and then times a tangent. But I know that tangent is sine over cosine. So if I rewrite this as sine over 1 times sine over cosine, that gives me sine times tangent. Ta-da! We did it. Okay? And I know you can go from the right over to the left as well. You could work it that way. But you can't do it in the same problem. All right, the next problem we're going to do was number 11. Number 11 says 1 minus tangent squared over 1 minus cotangent squared equals cosine squared minus 1 over cosine squared. So, as you can tell, This side's got tangents and cotangents, and this side is all back to cosine. So, we've got some options here. Also, when you look at your Pythagorean identities, this is 1 minus tangent squared. That's not what you have here. You've got a sum for the Pythagorean identity and for the cotangent squared. So even though that's 1 minus tangent squared, you're not able to use this. Okay? So that's unfortunate, right? The next thing to think about is I know that I need to take it all down to cosine. I need to get down to that basic cosine. So what I'm going to do is I am going to change this down to sine and cosine. I'm going to change each of those. The tangent squared, I'm going to make sine squared over cosine squared. And then we're going to have to get a common denominator in the numerator and a common denominator in the denominator. We worked one like this in day 2. Ready? Here we go. 1 minus sine squared over cosine squared all over 1 minus cosine squared over sine squared equals. Now I'm going to need my common denominator. This 1 is going to change to cosine squared over cosine squared. And this 1 is going to change to sine squared over sine squared. So that now my numerator has cosine squared minus sine squared over a common denominator of cosine squared. You rewrite that. Cosine squared minus sine squared over cosine squared all over, that's just the numerator. The denominator has sine squared minus cosine squared over sine squared minus cosine squared over sine squared. Now, I have a fraction in the numerator and a fraction in the denominator. So I am going to rewrite this, but I'm going to multiply by the reciprocal of this denominator. Okay? So I'm going to write the top one. So let's see, the numerator cosine squared minus sine squared over the cosine squared, multiply by the reciprocal of the denominator. Now I'm going to flip that sine squared up here, but I notice that this numerator looks very similar to this numerator, except they're flipped. Well, you have the power to flip them back. All you need to do is pull out a negative 1. So I'm going to kind of do that in one step here. I'm going to pull out a negative 1 times that numerator here becomes my denominator. So then, if I pull out a negative 1, I can write this as cosine squared, and then the sine squared is positive, but if I'm pulling out a negative 1, it's going to make it negative. Look what happens. Isn't that beautiful? Because now, put my equal sign, I have those factors and I can cancel them. Right? I can cancel cosine squared minus sine squared, and they equal 1. So now I have, and because of the nature of this worksheet, I know you're supposed to work vertically, so you draw a little arrow, say I am still working vertically, I'm working down, see my equal signs, okay? So now I have a negative sine squared over the cosine squared. And we are almost done, but that is where I'm going to stop this video, and when we come back, we will finish number 11 and then work number 13. See you then.